So hello everyone and welcome to this webinar on cloud data security threats and control measures. First of all, I hope everybody is doing well and staying safe wherever they are. So before we start, let me just do a quick round of introduction. So I'm Parag. I'll be your today's host and moderator for this session. I lead product marketing at Hevo Data, and we are joined by Les McMonagle, who is a chief security strategist at SecuPi. So welcome, Les, and thanks for joining us today.
Hello, everyone.
Yeah, so just the hygiene stuff before we start. So all attendees will be on listen only mode, and we are going to record this webinar and we'll be sending you the recording post this session. If you have any questions during the session, please type them in the Q&A window available on your screen, and we will address all of your questions at the end of the session. All right, so here is the agenda for today's session. I'll just give you a quick overview about Hevo as a product and platform, what it does and all, and then we'll give you a brief introduction about Les. Then in the end, we will do this Q&A session. All right, so let's get started. I'll just give you a high level overview of Hevo. So Hevo is a no-code data pipeline platform that basically helps you integrate all your data, which is spread across multiple sources. That can be a database, SaaS applications, or streaming services. All that data you can integrate in a warehouse, which is a centralized repository. You can use any platform, to set up your data warehouse, such as Redshift, BigQuery, Snowflake, and there are many other options available in the market. Now, this unified data can be easily plugged into any of the reporting analytics, that is BI application that you must be using currently, or you can also plug that in any of the business applications or marketing applications, CRM applications that you might be using. So this is, there are two aspects of it. One is you unify your data at the first place, and then you use this unified data, within the tools that you use. So this is how, the entire platform is set up. And Hevo provides 100+ pre-built integrations with different types of sources. And it also integrates with, all the widely used data warehouses and the business BI applications and business applications that are widely used in the market. All right, so now a quick introduction about Les. So Les is a data security strategist with over 25 years of experience in information security consulting and advisory services. He's skilled in data privacy, data security, data analytics, cyber security, and all other fields that are related to data security and compliance. So he is currently working with SecuPi as the chief security strategist, and has also worked with a lot of recognized brands globally, including Teradata. So that's in a nutshell about Les. All right. So with this introduction, I would like to pass over controls to Les.
Okay. Everyone see my screen okay?
Yeah.
Yeah. So in the session today, obviously it's, the subject is, cloud data security. We're certainly going to focus on that and different security considerations for going to the cloud, how to better protect data in the cloud, and as Parag said, lots of experience at doing this, working with large global banks. I ran the security consulting practice at Teradata for many years, almost 8 years, and have worked with a lot of different security product startups and defining product strategy. So lots of experience in the data protection space, both in Europe and the US, and quite a bit of experience in Southeast Asia also over the years. So when you look at cloud security, versus on-premise, right? There are some fundamental differences, obviously, between on-prem or cloud, but in the end, it's really still about protecting and controlling access to the data. That's the asset that's really important. Nobody cares if you hacked into a router or firewall or server in the cloud. What matters is if that allowed you to get access to, you know, some sensitive data. So we're really going to focus, this session is going to be on having a very data-centric approach to protecting and controlling access to the data, because that's ultimately where 80% of your effort should go in any cloud security strategy. So this is just the abstract. The key thing to pull out from this is the growth in spending for information security is certainly going up, but at a quite a bit slower rate than the cost of the data breaches and the number of breaches that are occurring. So organizations really don't have a choice but to find, you know, more cost-effective, more efficient ways to address some of these threats and better protect data. You know, it's really just a business imperative right now for a lot of organizations to be able to do that. And that's really what we're going to focus on is, you know, how to get the most bang for the buck from, you know, all of your efforts in protecting data as you move to the cloud and you try and take advantage of, you know, the financial benefits of cloud hosting. So when you look at different attack vectors, obviously we could talk about these for hours, all the different, you know, the 100 different ways that someone could attack your network, but then a month later, there's going to be 15 new ones that no one's ever thought about before, considered or factored into their strategy or their layered protection. So it doesn't matter what the attack vector is, the attackers only have to get it right once. The organizations protecting the data, they have to get it right all the time. They can't ever make a mistake. So this is why everyone has a layered approach to security. You don't rely on a single control, right, or data protection method for any particular attack vector. You think very broadly and more generally in terms of all the different potential or possible or common attack vectors, and then what mechanisms you can put in place to do that. So, you know, this is just a few examples that I put up even just from the last week, right? The kinds of data breaches and problems that occur that you've got to protect against, whether you're on-prem or the cloud. So trying to focus on single vulnerabilities and do something to stop each one of those isn't nearly as effective as having a good, consistent, well thought through layered approach to security and really thinking about controlling what ultimately everyone is after, which is, you know, the data. Okay, so the one common theme, of course, in all of this is gaining access to sensitive information assets. You know, 40 years ago, you know, and 30 years ago, it was, you know, popular to hack into somebody's, you know, internet website and deface their website and get bragging rights with all your buddies or something. You know, look what you were able to do. But nowadays, it's really, you know, organized crime and other, you know, sort of professional black hat hatters that, you know, make a living out of doing this, and they have to go after something that's of value. Okay, with the exception of ransomware attacks, pretty much all of the attacks are all about getting copies of data, you know, getting social security numbers, credit card numbers, and so on that have value to sell in the black market. So you really need to protect your data. And the other really important thing to think about when you're protecting data is this isn't like somebody stealing, you know, your cell phone or your car or some other, you know, valuable, your furniture out of your house or your TV or something. When those things have been stolen, you know they're gone, okay, and you can easily replace them and you're made whole again. But when it comes to data, your data can be stolen. You can be suffering the financial damage from that and yet not even know that anything has ever happened unless you have the right sort of monitoring capabilities in place that you can even detect that a breach has occurred. The vast majority of breaches are discovered long after the damage is done. And with data, someone can steal your data without actually taking the copy that you had. So it's a very different kind of animal to think about data protection, right? And the different kinds of mechanisms you have to put in place. You have to have a different mindset. So what can you do about it? Well, this data-centric approach, we're going to talk about this quite a bit because this is the one method that from my experience I've seen produces the best results, that puts you in the best position to immediately detect and proactively, you know, act on different data breaches rather than being, you know, purely reactive. a lot of the network layer types of controls, right? You know, lower level controls are really about catching the fact, something happening after the fact. You know, monitoring log data and things like that is great, discovering that a breach occurred, you know, minutes later, but sometimes it only takes seconds for millions of, you know, sensitive data records to be, you know, copied off of a database, for example. So you need to have mechanisms put in place so that that anomalous access is detected, even if you suffer from you know, a common data breach is, you know, credential theft, for example. You know, a very common healthcare provider in the US, for example, they had somebody was able to get a keystroke logger onto an end user's workstation. That end user happened to be the DBA responsible for a large data warehouse. And they were able then to log in remotely and use that person's credentials to now log into that database. And it was that DBA actually on the system that detected, you know, somebody running a query that was accessing tens of millions of records and wondered what was going on, and looked into who was doing it and saw that it was his own ID that had logged in doing that. Obviously, he knew that wasn't him. His ID had been compromised. He immediately killed the session, right? But the damage was already done. Tens of millions of records had already been copied. He prevented it from being worse. But you can't have just a reactive approach. You have to have a very proactive approach to doing this. So when you look at, you know, Gartner, this just happens to be their hype cycle for cloud security products, but you can see all the things that have reached that, you know, level of maturity, right? Where these are being put into production. They've kind of proven themselves out, and there's plenty of vendors in each of these areas, right, that you can consider. There's a few common threads among all of this. You can really boil down all of these vendor products that are, you know, really making it to prime time into, they're either detecting where your data is, classifying those information assets so you know what's the appropriate protection, where the really sensitive data is, and having positive authentication for anyone coming in, you know, two-factor authentication instead of just, you know, single-factor password only, for example. You know, purpose-based access control that's based on, you know, not just somebody's, you know, identity or just their role memberships, right? But on where they're connecting from, what application they're using to access the data, the time of day, the number of records that they're accessing, right? What department they're in, what is their nationality, right? What's their physical location, you know, which country are they in? All of those might have an impact on what someone's actually authorized or allowed to see based on different you know, rules or regulations that you got to comply with, or even just internal policies. So having good end user accountability, you know, when you're using a shared application ID from a Tableau server, for example, to access data, the database, any logging on the database has absolutely no visibility into who the end user is. They only see the shared application ID. So it's very important that you have end user accountability. And then finally, data-centric protection. And virtually every single one of these products can be boiled down into they're providing one or more of those features that are on the right. So when you look at data privacy regulations, these can really complicate cloud migrations, okay? You know, Schrems 2, for example, has turned a lot of the cloud hosting business, you know, upside down. This is a major concern for, you know, software as a service vendors and that, you know, originally set up their environments to be hosted physically in a particular, you know, physical location or data center, and, you know, they have a backup or whatever. But then Schrems 2 comes along, and any data on European residents can't be hosted in the US right now. So you need to move where that data is being hosted, or implement controls that logically achieve the same thing. If you can de-identify those records, right, with encryption or tokenization, and now they can be hosted someplace else, as long as the ability to re-identify them doesn't exist in that other jurisdiction, then you can be in compliance with, you know, geofencing or cross-border data flow restrictions that might be in place. So the important thing to keep in mind with all these privacy regulations is, first, you need to know which ones are applicable to your business, because these can drive requirements for, you know, fine-grained access control based on physical location and things like that. And you know, the level of encryption or tokenization, de-identification or anonymization that you have to put in place. And even though your business might be global, these regulations are still local. You still have to think carefully about, you know, data localization, data sovereignty, right? You know, logical versus physical location of data. All of those are going to have an impact on your, you know, security architecture design for your, you know, cloud. So when you look at cloud provider responsibilities, this happens to be from AWS, but this is essentially the same at Microsoft and at Google. You know, on the bottom in the orange are the things that the cloud providers are going to be responsible for. You know, they'll put in software upgrades, you know, for your Oracle database that they're providing you, right? Or your Snowflake database and so on. They'll provide all the compute and the storage servers that you need. They're going to, you know, own configuration and management of all of the network router components, physical security, and etc. Right? You know, there's certain things that security of the cloud itself that they're responsible for, but they're very clear. All of the cloud hosting providers are very clear about the security in the cloud as a customer responsibility. Okay, it's up to the customer, for example, to decide where data needs to be encrypted, where it needs to be, you know, encrypted and decrypted, and who controls the keys and where the keys are available. All of these can have a significant impact on privacy compliance requirements and regulations. Same thing for network traffic. You know, obviously you're going to protect the data going to and from that, right? But how are you going to control identity? Who's going to control those keys for doing that? Okay. The platform applications and identity or access management. These are all things that the company hosting their data in the cloud have to be responsible for. You basically still control your data, you control the people who access it, and you control the applications they use to access it. The cloud provider is looking after everything else. But just those three things are a big part of the picture. Never assume that your cloud provider is somehow going to make you, you know, PCI DSS compliant, or that they're going to make you, you know, GDPR compliant or CCPA compliant if you're in, you know, California, for example. It's up to the actual organization, and they're very clear about this contractually. So if you look at sort of what's underneath those sort of high level functionality, right? AWS, and again, there's the equivalent that, you know, I wasn't going to waste the time, you know, in this presentation, basically showing you virtually the same thing for the other, you know, two major cloud providers, but Azure with, you know, Sentinel and so on, Purview, you know, all of the Microsoft, you know, capabilities, Active Directory, you know, in the cloud and so on. They provide virtually all the same sort of baseline security features. Instead of S3 buckets, you've got Azure blob files, right? All of the logging, the network traffic and so on, you know, instead of, you know, RBAC on Redshift, you have RBAC on, you know, SQL Server in the cloud, okay? Very, very equivalent. Down near the bottom there, you see the ISO, you know, NIST certifications. You'll see that all these cloud providers have spent the time to go and get independent third-party, you know, audits against, you know, their controls against these different, you know, ISO standards, NIST standards, and so on, or performed, you know, SSAE 18, you know, audits on their, you know, network controls. But they're only certifying the areas that they're responsible for. They are not certifying anything else. All that higher level stuff that's the responsibility of the customer, none of that's included in this certification. They're only certifying that they have good physical security in their data center, that they have two-factor authentication for their admins getting in and out of the data center, that they're, you know, they have monitoring of all of their network traffic and router configurations, etc. The parts they're responsible for is what they're certifying, not your entire infrastructure. So those certifications aren't worth a whole lot if you're looking for compliance, and you certainly can't, you know, use those as a reason for saying that, oh, we did everything we could to protect the data. Look, we had it, you know, certified or audited. Now, they have other value-added services that they usually charge a little extra for, okay? You know, using AWS Security Hub and so on, right? You know, setting up Nitro enclaves, right? You know, bring your own key capability, KMS, right? You know, if you want to have Amazon be responsible for managing and generating your keys, they can, you know, offer you a KMS service that'll do that for you, your key management system, you know, a software version of an HSM. They can let you bring your own keys. You give them the keys and they'll use it. But all of that is still the keys existing in the cloud provider. Even if you're being responsible for giving them the keys, you're still sharing the keys with the cloud provider. So when all of these, you know, baseline or value added services aren't enough, then you have to start looking at other areas. Okay. And this is where you need to start looking at other vendors. You know, you might need a column level encryption solution. You might need to comply with different geofencing or geolocation restrictions, you know, enforcing right to be forgotten requests, right? Or responding to DSAR, you know, data subject, you know, access requests, right? For, you know, who are all the people that have looked at, you know, my data over the last 30 days. All of that kind of functionality isn't going to come from the cloud provider. You have to be able to provide that as part of your security architecture, right? And processes that you're putting in place for protecting the cloud. Okay. And a lot of this can come from a single vendor, or it can, you know, sometimes come from, you know, multiple vendors. So when you look at a data governance strategy, then some of the essential components of any data governance strategy, you know, when you're, especially when you're, you know, migrating to the cloud. First, look for ways to reduce the data. You know, only keep sensitive or regulated data that you need to run your business. There's no point in adding additional exposure and risk for no business benefit. If you have sensitive data that has no business value, you don't need it, you're not using it for analytics, you're not gaining any benefit from it in any way, then get rid of it. Okay, their scope reduction and keeping only what you need first and foremost is important. And then, you know, using anonymization or masking. If you have a data set that just de-identifying it, right, or anonymizing it, you still need it. You still want to look historically about what your clickstream, you know, patterns were like, you know, and how they change over time. But if it no longer is necessary to associate it with an individual, then keep only the anonymized data, because the sensitivity of it drops dramatically. It's no longer PII. It's no longer subject to data privacy regulations and so on. So always look for ways to reduce scope, reduce risk without impacting the business. Okay, be smart about what you keep and what you don't keep. The data volumes will grow faster than, you know, available space to store them. So it's very important that we get smarter and smarter about this. You know, globally, the world passed the point a few years ago now where data was being generated worldwide at a higher rate than all the combined organizations that manufacture disk drives and storage capabilities and so on, faster than they were producing the hardware that could store all of that data. So we have to continue to get better and better about only keeping what we need, because so much data is being produced. So once you reduce the scope, you also need to make sure that you have a good inventory, catalog, and classification of that data. You got to know what data you have, and, you know, what's sensitive, what isn't, what's regulated, what is personally identifiable, or, you know, protected health information, what is PCI data, etc. Right? All of that's very, very important. Data owners should have a clear picture of where all their data is. Then you need to have, you know, centrally managed, consistently applied controls for this. Okay, if you try and build, you know, role-based access controls on every single database, every single application independently, you know, view layer security or application specific, you know, role-based access controls, it will become virtually impossible to do that consistently across all of your different platforms. So just that alone is going to leave gaps and holes in your security that you can't watch all of those doors all the time. So if you can have centrally managed, consistently applied rules, you know, central door locking in your car, you can click one button and all the doors in the trunk all lock, lights go off and everything. You push one button and they all unlock. That's much better than having to reach around or walk around the car and lock each door individually, because every once in a while you're going to miss a door and you're going to leave one of your back doors or your trunk unlocked or whatever. So centrally managed, consistently applied rules are very, very important. And then you want monitoring and reporting on this. You need to be able to especially watch access to the sensitive or regulated data, the crown jewels, the stuff that matters, the things that any hacker would be interested in getting. Nobody cares about stealing your clickstream data, but they'd love to get a copy of your customer table that's got name, address, phone number, email contacts, social security numbers, credit card numbers, and so on, inside it. So you need really good monitoring, auditing, and reporting on all access to your sensitive data, and to be able to watch those patterns over time and detect any anomalous access, any excessive access, any unusual access for a particular user or group of users, or a particular application accessing things that's not normal for that application. And then, automated policy-based compliance with the different regulations. We touched on the regulations earlier. It's not only knowing what they are, but putting in place mechanisms that are ensuring that you're complying with these all the time, because you have to be able to prove that. You have to be able to show that you're implementing, restriction of use, right? That you have records of processing, right? All of these privacy regulations are substantially, similar. There's a clear convergence of internationally accepted privacy principles. So any new regulations tend to keep converging on this standard acceptable, privacy principles. Okay. GDPR is just a later manifestation of that, right? But there's plenty of other regulations around the world, whether it's Singapore, Thailand, Philippines, and so on, India, that are all basically doing the exact same thing. And there's subtle differences between the different countries. And then finally, your trust model definition. This is one of the most important things to think about in defining your data governance strategy, okay? The trust model is, who do you trust and who do you not trust? Where is it okay to be in the clear and where is it not? So if you want a zero trust network architecture, for example, for going to the cloud, that might dictate that only anonymized records can go to the cloud and the keys to decrypt can never exist in the cloud. And that's the only way, perhaps, that you can feel equally confident in that data as being just as secure in the cloud as it is on premise in your own data center. So your Teradata data warehouse on premise or Oracle database on premise might be okay if it's in the clear, because you've got really good controls over it and you can immediately shut it down, etc. But to take that same customer table and host it in Snowflake, at Microsoft Azure or at AWS or something, might require that you de-identify that data. So that's the kinds of things that would be decided in the definition of that trust model that the organization wants to put in place. So let's look at a couple different case studies, okay? And these are just a few examples that I pulled out that had a lot to do with cloud migrations and really touched on all the kinds of things that I've been talking about. So this first one obviously was one of the Blues here, Blue Cross Blue Shield Arizona. Their big concern was, for over a year, they wanted to start hosting things in the cloud, but their own internal information security people said, no, if we put this stuff in the cloud, we're not going to be HIPAA compliant. Their interpretation of, what was required for HIPAA for HIPAA compliance was not being met by what was being proposed for moving that data to the cloud. So they needed some way to enable them to take advantage of that cloud hosting. And the thing that worked was being able to de-identify the records before they go to the cloud. So you can see over in the left, right, on their ingestion, they were using, multiple different ingestion tools. It doesn't really matter what the tool is. What's important is, fundamentally, before the data goes to the cloud, it had to be de-identified. And that de-identification means, taking any personally identifiable fields, the name field, phone number, email address, social security number, anything that could associate a record with an individual had to be protected in such a way that it's not available in the clear anymore, okay? But you also still want to maintain referential integrity. So if you protect the social security number column and you replace the real number with a, fake number or a tokenized version of a social security number, that's hosted in the cloud, you might still want to use that column for table joins or for, lookups and things like that, right? You might want to get a result set that then can be brought back on premise, and then an authorized person or business process can, re-identify those records and get back to the real social security number, for example, or name or whatever it is. So it's very important that you have a mechanism that lets you de-identify those records, perhaps as part of your ETL process or processing the load file that you're creating to load to the cloud, right? Or as part of the actual load into the cloud. At some point in that data flow, you want to be able to de-identify those records so that you see down here, the original data, it's John Smith and his real social security number, but what gets stored in the cloud looks like gibberish, except it's the same identical gibberish for the exact same, John Smith and the exact same social security number, okay? But the ability to re-identify it doesn't exist in the cloud. It doesn't matter if you're using Hive or Spark or Snowflake or AWS RDS or Redshift and so on, right? SQL Server. All of that data in the cloud will only be de-identified records. And then on the consumption side, whatever tool or method you're using to consume the data, even direct, data scientists with a, Jupyter connection directly to the database in the cloud. They can have, agents installed that provide the re-identification only for authorized users based on, a wide range of different attributes, not just their role memberships, right? The application that they use to connect, where they're connecting from, as we said earlier, might all have an impact on what they're allowed to see when they access that data in the cloud, okay? So it's very important that you have some method that's going to have only de-identified records in the cloud and only re-identify for authorized users on consumption again. And with this particular one with Blue Cross Blue Shield, their key things were, as I mentioned, the hold your own key capability where data is encrypted in the cloud, but the keys are kept on premise. They're never shared with the cloud provider. So you always want to look carefully at any encryption solutions. You can imagine then by definition, any encryption solution provided by the cloud provider itself, their KMS and so on, automatically breaks this rule because a wayward admin at that cloud provider or AWS being subjected to disclosure requests from the US government, for example, for a company with European customers, could all mean that they've got to turn over the keys to access that encrypted data. If the data was encrypted in Germany before it ever left Germany, and it can only be, decrypted back in Germany, then it doesn't matter about the Patriot Act and the Cloud Act and so on in the US. That's not going to impact that data being exposed, and the data subjects in Europe, their rights are still being, fully, their privacy rights are all still being enforced, okay, within the jurisdiction of Europe itself. So it's very important to keep that in mind, the difference between hold your own key versus any bring your own key or cloud hosted, key management infrastructure. And then the other thing is, the other key thing that this particular customer really needed was real-time activity monitoring, right? User behavior analytics. They knew because of, all the recent data breaches, of, their, peers and competitors and so on in the US, that lots of breaches are occurring in the healthcare space, health insurance, health provider space, because they tend to not have as good a security, let's say, as the large global banks, for example, around sensitive or regulated data. And if they've got the same social security number, name, address, phone number, and so on, then that's almost as good getting into there as it is getting into that customer record at a bank, for example. So the real-time monitoring, they wanted to be able to detect anomalous activity. They wanted to be able to see if a particular user's credentials were suddenly being used just in a different way. There might be an authorized query to the database. That user identity might be allowed to see certain data, but why are they accessing data, following a profile or pattern that's not normal for that user? So they wanted that kind of, anomaly detection capability too. That was a requirement for them to be able to move to the cloud. Okay. So very, very important to think about all of those things. Another one, again, large global manufacturer. they were looking to have a, major cloud transformation, corporate strategy. Their long-term goal for IT is to move to the cloud. Okay. But they realized in order to do that, it was going to mean switching from a whole bunch of on-premise platforms to a whole bunch of cloud provided platforms. And they knew that once they go more global and more centralized, they're going to have other requirements. Their trust model basically said, look, we need to de-identify this data before it goes to the cloud and so on. We need to control access based on a lot more than just somebody's role memberships. So even though they were using a wide range, they happened to be on AWS, that was their main focus, but they did also have, there's some things that they host on other platforms, for example, because they also didn't want to commit all of their business to a single cloud provider. They wanted to make sure that they had healthy competition between them. So, their goal is also to have some things on, Azure, some things on AWS and so on, and, have this hybrid cloud type of environment. And then there's some things that still just have to be on premise. They can't get around that. But what they did realize was they wanted to control access, not just based on role memberships, but based on all kinds of other user attributes. Okay. Based on the application you're using to access the data, based on your physical location. Are you in the office or not? Or are you connecting over a VPN? They would have contracts, with the DoD or military where, certain equipment, somebody had to be a US citizen to even know where that equipment was, for example, to know its physical location, right? For, ITAR compliance, etc. So they needed to be able to control access based on a lot of different user attributes and apply that consistently while having the data mobility to move data from one platform to another, to move from one cloud provider to another without having to start over. So really important fundamental sort of requirements for a truly flexible hybrid cloud migration for their IT operations, and to do this in a way that the rules could follow the data. Okay. So a major cloud transformation project. They needed that centralized authorization and access control for both on-prem and hybrid cloud. And they needed this finer grained sort of purpose-based access control, not just role-based access control. They were struggling to model their requirements under that. And they wanted these controls to apply to a wide range of different platforms. And more importantly, not just the ones that they thought they were going to use initially, but they were looking for a solution that could scale and grow and be flexible to meet whatever their requirements are in the future. If they stop using Snowflake and they start using RDS, for example, they don't want their security model and their trust models to have to change. So when you look at cloud migration strategies checklist, okay, spend a few minutes just, sort of assembled a list of things that you should think about or consider whenever you're, involved in any cloud migration strategy. First, establish that data-centric, risk-based approach to this, okay? Don't just automatically start off with, oh, data must be encrypted, or data must be this, or we can't copy that. Instead of some blind rule that is just pulling it out of the air, have a real risk-based methodology. What are the risks? What are the attack vectors? What can you do to address some of the more common attack vectors, right? Really break it down into the component parts to think about what the different layers of your security model should be, okay? But absolutely, it has to be data-centric because that's ultimately what you're trying to protect. Knowing your data, where it is, having it classified, knowing who the data owner is, who decides who gets to see what data under what circumstances or sets of conditions, right? Who says whether you have to be a US citizen to see this or not? Well, that's got to come from the data owner. They might consult information security, privacy, compliance, legal, subject matter experts in a company, but they're the ones that have to make those decisions, okay? Defining that desired trust model, as I mentioned earlier, okay? On-prem might be very different from when you move to the cloud. If you want that zero trust network architecture, for example, in the cloud, then that means putting certain types of controls, de-identification and things like that in place, so you can confirm that this is a zero trust architecture. Document all of your access control requirements. There's no point in trying to start building access controls or data protection without actually knowing what those are supposed to be. And these need to come from the data owner. These can't come from IT, okay? Someone in IT should not be making those decisions, okay? They should be given the marching orders by the data owner. If the data owner doesn't know, because that's not their area of expertise, they should be consulting with legal, information security, privacy, compliance, and so on, experts within their organization to do that. Geofencing and data sovereignty, cross-border data flow restrictions, right? Is Schrems 2 compliance going to be an issue? All of these have to be considered in designing your architecture, where the data is going to be hosted and so on, okay? How you're going to manage those cross-border data flows. Consent and preference management. Customers are going to opt in and opt out of different things. You need to make sure that you're staying compliant with that. There's lots of tools, for example, that do a great job of giving your customers, let's say, or some companies' customers, a nice GUI interface and website that they can go to, and they can check boxes and pull from drop down lists and so on, and they can say exactly what their preferences are for what their data can be used for when they become a customer or a member or something like that, or sign up for your program, right? You give them really granular control over how you're allowed to use their data. Okay, that's great, except most of those tools only do a really good job of tracking that information, not actually applying it or enforcing it. The rubber really hits the road when you have to actually enforce those rules consistently. When someone exercises their right to be forgotten, you can't just go and delete all of their data from 70 different databases and applications, right? That you might have data on that customer spread out throughout your IT infrastructure. You've got other data retention requirements. If you're a bank, for example, and it's financial records, the IRS in the US requires you to keep that data for 7 years, right? So even though you might immediately exclude that customer's records now from a new email marketing campaign, you still need to keep that data for reporting last year's sales figures or profitability, for example, right? Doing different SEC reporting. That data still has to be available. Maybe it only has to be available in an anonymized form, so it's just aggregated data, or maybe it's got to be still available to the IRS for audits, where they want to see the records 7 years back for a particular company or individual. So managing those preferences and tracking them is one thing. Enforcing them consistently across your organization is the really complicated part. Okay, the records of processing, being able to keep a record of who are all the people that looked at a particular customer's record. A celebrity checks into the hospital, and then suddenly 3 days later in the news, there's this leaked news report that this person went into the hospital and they got this and their x-ray said this and so on. Somebody is going to want to know who are all the people that looked at those records, right? Who leaked that information? Who is the unauthorized person that looked at that, celebrity's records when they were in the hospital? So it's very important to have very tight controls and monitoring and audit trail and user accountability around all access to any sensitive or regulated data, so that you can, support, right to be forgotten and DSAR requests, etc. And then just access monitoring and alerting, being able to detect anomalous activity or unusual or excessive access to data that could be an indication of some form of data breach that you've never thought about, some attack vector that you've never heard of before. It's a brand new way to get in, but it still ultimately results in unusual or suspicious looking access to the data, because ultimately that's what they're always going to be after, is the data. So that's the thing you want to watch the most and the closest. And then user behavior analytics, being able to, visually represent that access to detect, anomalous activity. The data mobility, any controls that you put in place, it's very important that they're platform agnostic, that they can follow the data. Anything that's hard coded into view layer security for a particular database means that moving that data to some other database means starting over again and rebuilding all of those controls. So just trying to model the identical controls someplace else is really difficult. And then, integration with other complementary solutions. You want to make sure that your overall architecture and design and strategy looks at all the components that you're going to have to bring together and how they're all going to integrate together or play nice together, right? How they're going to share information, how they complement one another, right? To make sure that you're not, having a lot of, unnecessary redundancy. And then all of this really boils down to privacy by design. Build privacy, compliance, and security into what you're building right from the beginning. Make that a fundamental basic requirement so that you're not trying to bolt it on later. Trying to add it on later will always be an order of magnitude more expensive than building it in from the beginning. Okay, stop now and we'll start looking at any questions that anyone might have.
Great presentation, Les. Thanks a lot for sharing all the insights. All right, so now it's time for Q&A. If you have any questions, just type them in the Q&A window available on your screen, and I'll just read them one by one. All right, so here is the first one. How to evaluate third-party SaaS tools from a data security, privacy, and compliance perspective.
I'm sorry, could you repeat that, Parag? Sorry.
Sure. So how to evaluate third-party SaaS applications from a data security, privacy, and compliance perspective?
Okay, yeah, very, very good question. As we talked about things like geolocation and so on, right? What are the security controls that SaaS provider is going to give you out of the box? There's things that they're going to give you as their baseline security controls that it's up to you to take advantage of all of those. Then they might have other value-added services that you pay extra for. Here's our baseline security, but for 20% more money, we'll give you these 4 additional, security measures that can be, added to our product, for example. So some of the major SaaS providers, Salesforce and so on, they all have, the standard baseline data protection and security, and then they have more advanced features. But you might have, depending on the data you're putting in there, that might dictate, for example, where Salesforce can host that data, where it's going to be physically located, cross-border data flows, and so on, right? All have to be taken into consideration. If you remember our diagram where we said what the cloud provider is responsible for, well, that's basically where the SaaS providers are too. They're not there to control your data. They're not there to control your identities. They're just providing you one application for accessing your data. You've got to tell them any restrictions on where it should be hosted and so on, that underlying database. So you need to look at all these things that we were talking about and just apply those to a SaaS provider, just like you would any cloud provider.
Absolutely. Yeah. So we discussed about this cloud migration strategy from security and compliance point of view, right? So there are 2 aspects to it. One is either migrating from on-prem systems to cloud. And second one is you are already using one of the cloud vendors and migrating from one vendor to another. So how do we ensure complete data security and compliance while migrating from one cloud vendor to another?
Yeah, so when you're doing that, if you build your whole security infrastructure based only on that cloud provider's provided capabilities, then the identical things won't exist. Equivalent things will exist. Microsoft does a pretty comparable job to Amazon and to Google and so on, right? All the major cloud providers will provide, 90% of what they provide will be similar or equivalent, right? But they won't be identical. It's going to mean starting over, building the equivalent things in their tools. So any of your controls that are dependent or reliant on the cloud provider or their hosting, cloud provider, specific, right? They're not going to transfer to another cloud provider. So you want to have as many of your security controls and data protection and so on to be platform agnostic, to be cloud provider agnostic, to be application and database agnostic, so that those rules and policies that you're defining, they're going to follow the data from one place to another. Very, very important aspect of that if you want that data mobility or flexibility.
Got it. Here is the next one. What control measures an early stage startup should implement to prevent any data loss or theft?
I'm sorry, could you repeat that again?
Sure. So what control measures an early stage startup should implement to prevent any data loss or theft? Considering that an early stage startup might have limited resources to use.
Okay, yeah. So a really small startup company that literally isn't going to have their own data center. They might be purely reliant on a cloud provider. But then what they should do is, instead of using just, out of the box standard, public features of that cloud provider, is consider, for example, standing up a virtual private cloud or a VPC within that cloud provider. And then, paying that little bit extra to have their own dedicated, virtual machines, Docker containers, Kubernetes clusters, and so on for running their infrastructure. So it'll still be a lot less than their own environment. But if you have a VPC, then you have a lot more control over everything that happens inside that VPC. Amazon and Azure and so on, Google, they'll all set it up and configure things any way you want. They'll still look after the hardware for you, but it'll give you more control over, router configurations and firewall configurations and so on, right? Than you would have if you used only generic services. If you only use, Salesforce, and you only use, Tableau, SaaS and so on, then you're going to be much more reliant on what are sort of the generic out of the box controls of those different vendors. But you're right, it might be harder for a startup company to, handle all of that financially. You might end up having a lot more exposure than you'd like. So that goes back to that thing I mentioned earlier, right? One of the first things you do in any cloud strategy is reduce scope. Only keep really sensitive data. What's the data you really need that could be regulated or sensitive data that you're going to put in the cloud, and always limit that to only what's absolutely needed, right? Keep your exposure, right, to a minimum.
Absolutely. One more question on the startup side. So as the limit, as the resources are limited, so how often a startup or any mid-sized company should do a security audit? How often the security audit should happen for these companies?
I guess as a general rule, you would never want to go, less frequently than once a year. But I think that's more dependent on how rapidly your system or your environment is changing. If from week to week you're switching data to different cloud providers, right, and you're moving to different SaaS applications, if literally every week you look at it, you've got a quite different IT infrastructure than you had a week or 2 weeks earlier, then you might want to have those, reviews much more frequent. Okay. Again, what's more important is not to let IT build whatever they want and then try and audit that and look at the controls after the fact. What you should do is define all the requirements up front, so that every single thing that's being built, it's being built with security built in, privacy by design, right? Build it in versus bolt it on, because then you're not relying on some audit a month later or once a quarter or once a year, to detect any vulnerabilities or issues or gaps in your security. Okay, those should always be like an ongoing thing that you're doing. The audits should just be as a sort of a final, way to catch something that you somehow missed through your other process, and more importantly, to improve your design and development process. If you realize, oh, look, we introduced these 3 additional risks because we didn't have the right mechanisms in place for new application development to stop those from getting introduced into our environment in the first place. So then you adjust that, software development model, right? Or your strategy around building out your IT infrastructure so that those things don't appear. I would never rely just on audits on a monthly or quarterly or annual basis to solve or find all of your security vulnerabilities.
Absolutely, got it. Here is the next one. How safe is my data with no exposure to anyone and hosted on Kubernetes MySQL cloud clusters?
Yeah, so the data is as secure as you trust that cloud provider and any of their security admins to access the data, okay? But if you're hosting that, for example, at a cloud provider that's based in the US and that's got data on European citizens, even though you haven't granted access to anyone, if that personally identifiable information is in the clear, sitting on a US server, okay, then it's subject to the US Patriot Act and the Cloud Act, which means it's in violation of GDPR, especially, with Schrems 2 now, okay? So there is no blanket protection for US hosting companies to have, European citizen data sitting in the US. Your only choice is to de-identify those records before they're moved to that database. And the keys have to remain, in Europe, in the particular jurisdiction inside Europe. So even though you haven't granted access to the data, you still have a liability and a risk exposure there because you don't have complete control over that cloud environment. You're trusting the cloud provider to do that. Their security might be better than it would be in your own data center, but you're still trusting them to do it. So it's kind of a, a contractual issue for managing security. And it's a risk, management decision that you've got to make, right? Is that more secure than if you had it in your own data center? If it is, then you can justify that and explain that you took the steps necessary, but you might need to think about where that data is going to be physically located and who can access it.
Perfect. We'll take one last question. So how has remote working impacted the security threat landscape?
That's made a big difference because it's really added another dimension, right? It used to be that companies would have, 5, 10, 20% of their, workforce at any one time connecting over a VPN, let's say, into their network. But now they might know, because of COVID, they may have 90% of their workforce or more connecting remotely. Okay, so that's always a big issue. It's just another parameter to take into consideration when you are designing your security architecture and the controls that you need to put in place.
Got it. Thank you, Les, for answering all the questions. So that's about it for this session. I would like to thank all the attendees for joining us today, and special thanks to Les for sharing all these valuable insights. If you have any questions or feedback about this session, then please write to me at parag, parag@hevodata.com. Also, we are hosting our next webinar, which is on data virtualization, trends, best practices, and future outlook. It's on 8th of September. So do register for this session, and I will see you there. Till then, take care and stay safe.